Okay, so we've discussed problem decomposition and recognition and the features of problems that make them solvable. How do you put this all together to answer some of the OCR's past paper questions? Is another topic entirely, kind of. For example, this one is a 2023 paper. It's in the link below, in the article below, and I've got my model answer here. I'm just going to talk through it a little bit. So basically, there's a company and they want to create a program that will create schedules for delivery drivers, a bit like Uber Eats or something. It will need to identify a possible order that drivers can deliver items and possible routes they could take. So discuss how programmers could make use of problem recognition and decomposition when designing the system. And so you've got to talk about all the things that I just discussed in the previous video. There should be a link, or if you're looking on the playlist, you'll be able to find that, but it will be the one before this one. Include in your answer, you want to describe both the problem recognition and decomposition. What are they? How each method can be used when designing the solution, and the benefit of using each method when designing the solution. So the way I started to think about it was, well, if we're going to recognize what this problem is, let's go back up to here. So we're looking at, well, is there a problem that needs to be solved? Yeah. What's the nature of the problem? What data are we going to need to get? And then what variables are in play that could alter the current state of the problem? And then what processes that what's our solution that we're going to say that we're going to make out of this, that we're then going to decompose. So looking at their system, they're saying they want to create schedules for delivery drivers. So it'd be in order to identify a possible order that drivers can arrive and deliver items routes as they could take. So efficient route planning. I think there's a problem there. We're recognizing that problem there. Timely deliveries, minimal overlaps. So you want your drivers busy all the time. You don't want them to deliver somewhere and then have like an hour or half an hour wait before they get another job in, just because they're too far away from a different location or whatever. So you think about how Uber Eats works. It's not just about how far the delivery driver is away from the customer, but it's also about how far they are away from where they need to pick it up, and whether when they arrive, whether it'll be ready immediately, and then they can head off to the next place, head off to deliver it to the customer so it arrives hot and still fresh. So we need to understand, in recognizing this problem, what the requirements are. So perhaps when you're discussing recognizing the problem, you could say that you would need to go out and investigate it, look at data in the system, look at the problems that they've already got. Perhaps they do have a lot of drivers. You could say to recognize the problem, you've got the data, got the information from the drivers in which they've told you that they spend a lot of time waiting around for new jobs. So we need to fix that issue. And then, so what's the advantages? What's the benefits of breaking this down? Well, we're going to have a more focused solution. We'd be able to define clear objectives for the system. We're going to be able to reduce travel time and maximize the number of deliveries. So once you've decided what the problem actually is, once you've recognized it and you've described that, so we're recognizing a problem so we can identify the issues, we can figure out what things are needed in this new system, and then how we're going to apply it and the benefits of it. Then you need to come on to describing how you decompose that. So why would we want to decompose that problem? Because if you break things down into smaller, more manageable parts, then it's easier to solve it. not only is it easier to solve them, it's easier for developers to pick up those issues and work on them and say whether or not they've successfully done them. Also, if you decompose a problem, for example, we've said we're going to break it down into efficient route planning, timely deliveries, and minimal overlaps. You could then design specific algorithms to solve those specific problems. So we can create specialized algorithms. For example, a route optimization algorithm. So an algorithm that will help the driver get to that location by avoiding traffic and make sure they get there just as the food is ready. Or we could possibly use graph theory. So if you understand Dijkstra, the shortest possible path and the heuristics that are involved in that. And then in terms of figuring out which things need to be delivered first, or so to keep the customer happy, maybe you want to look at queues. Queues are first in, last out. So as the orders come in, they join at the back. But is there ever a reason that an order of a customer needs to be prioritized and skipped some way of the queue, or skipped to the front? Perhaps it's perhaps they've paid for a premium service or something. Yeah. So what are the advantages then of decomposing this problem? You know, we recognize what the problem is: efficient route planning, timely deliveries, minimal overlaps. The point of recognizing the problem is so that we can make our solution more focused on those issues. Then we've decomposed this problem to come up with specialized algorithms to solve each of those parts, to allow developers to be focused on things that they've got to develop. We break those things down, right? You've got to make the algorithm to do this, and you've got to make the algorithm to do this. But also the other benefits of decomposing the problem is it makes testing and debugging things easier. So if we said what our requirements are at the beginning, so you know, we need a system that's going to do this, this, and this because this is the problem, and we've decomposed it into these solutions, you can then go out and test whether those solutions really do the things that you wanted to do. So maybe go and have a think about this yourself and try and write up your own answer, and read through my answer, but also have a look at some of the other questions here, past paper questions on decomposing a problem. There's one here about a computer game, another one here which is a bit easier, describing what abstraction is and why we need it in solving problems. But this one was probably one of the hardest ones I've seen in terms of understanding the need for problem recognition and decomposition. So it's worthwhile discussing that.